Hello, my name is Christian Kiep from the company ProKNX. We are specialized in voice control for KNX. We started already in 2016 with voice control with Siri, Google Home, and Alexa. And in 2018, we started with our own system, which is an offline system without cloud connection. It's based on SNPs. And today I'd like to show you some advantages, disadvantages of these different systems. So here I share my screen for you. Here is the summary of the speech that I want to show you today. First, I will show you some user worries about smart homes that are existing today. Why should I be concerned about privacy? Then I'm doing a short look at the cloud-based voice control system and an offline voice control system and thoughts about the security about these. And then I'm covering a bit aging in place because voice assistants are really very interesting to accompany aging people in their home when they're living alone. And finally, I will show you our products Aragon for offline voice control. So here is a survey of the last 6-7 years. In 2014, the worry of privacy security was not very high. So you see here in the beginning, only 30% of the people that has been asked were worried or with privacy, but this in 2016 and 2019 has been almost doubled. So it seems that there has been some major changes in this area, and you know that 2016 Alexa started with the voice control, and I suppose it must have been something about that. Then you see also the interoperability. This was very small, tiny concerns in the early years, because I think there hasn't been a lot of systems in the market. And with the systems that are now available, the interoperability is less, of course, and so the concern about it is very high. The costs indeed has been lowered. In the beginning, the cost has been a major problem for the investments, but today it's rather low. It's 50%, it's still high. So why should I be concerned about privacy? I would like to give you an example with Alexa. Alexa has today, Amazon has today over 40 million customers accounts in Germany. And these accounts are collecting also data, contacts from the mobile phone, unless you disagree. It determines the location where you are. It is recording the spoken data with Alexa, and it's evaluating them. And then with every spoken text, my personal life becomes more transparent. And this is because there are heavy machine learning processes behind of these spoken data that are analyzed. It's not a question of hiding our data. It's a question of sharing my data. You see, I become vulnerable and influenceable with these data that are known from me. And if I turn on the light in the evening when I'm coming home in my house, then I'm also close the curtains because I don't want to share private data, and it's not necessary especially. So I will show you now the data flow for an Alexa voice control for just turning on the kitchen lights. So I'm here in my kitchen, and here's the kitchen light, and I'm saying to Alexa, "Hi Alexa, turn on the kitchen light." Now what's happening? These data are sent to the Amazon server outside. I think it's even in America. Here they are also recorded, and then they state that this concerns a skill. A skill means that the answer cannot be returned directly to the Amazon speaker, but it goes first to the skill server. You know, when you activate a skill with Alexa, then you have to define your user account to make it, to activate it. And then with this user account, you are able to connect to the skill. So afterwards, here is your gateway from your home, and this gateway is connected to the skill server that you have been activating. So the data is flowing from the Amazon server to the skill server, and the skill server, the skill will determine that it's the kitchen light that has to be turned on. And so the command, the KNX command for the kitchen light is activated here, and this will be shown to this will be sent to the gateway here, then to the gateway to KNX, and then to the kitchen lights. So it's a rather complicated way to turn on the lights. If I show you now the security of these cloud assistants, perhaps it's a bit varying, because, you know, the data security of the online assistant is dependent on the skill and the skill server. So the house is really open via the skill, because the communication between skill server and your house must be always open. And the access to your house is available through this skill server. So you have to be very confident to the manufacturer of the gateway, because otherwise, well, if the gateway has the secure access to your home, it's not only you that have access to the home, it's also the gateway manufacturer. And so you have to be confident to him that he really makes sure that your data are secure. I will show you this again in another example. If you want to, if you have an internet request, for example, I want to see at what time my plane goes to Berlin. So I do my internet request, and at the other side in the internet, there is a server that's hearing your request, and then the server will answer to you directly, and you're hearing the time when the plane will leave. So you see, it's one way, it's on one port. It's not one way, it's two-way communication, but it's only one port. You send out a message and you get a message back from an endpoint that you know, because you ask this endpoint. Now with Alexa, it's a bit different. You're requesting something. This goes to the Amazon server. He's hearing it, and then it's going to the skill server, which also receives this message. And then the skill server will answer, and you get a message back from another third-party system. It's not the same system that you're asking for, it's another system. And that's the reason that here, when you're hearing it, this door has to be open all the time from the skill server to your home. This is really a security point that has to be covered. Well, here again, you can see it. This is the way to the Amazon server, here to the skill server, and here's a second way which has to be kept open all the time. Otherwise, you cannot use the Alexa. That's the thing about data security, but you have also the problem of the operational security, because the Amazon Alexa needs a lot of functions, as you have seen. There has to be a functional internet connection, then an operational functioning of the Amazon server, then the function of the skill server, then the function of the remote connect service to be connected all the time to the skill server, the function of the internet router in your house, of course, and also the local gateway. So a lot of things are necessary that Alexa will be operational. It has to be, it's rather nice. You can be happy, at least if it's working, to my opinion, because there's so many problems that may occur in the meantime, in this long way where the command will be answered or treated. Now I can show you another way of voice control. Here we have the offline voice control data flow, and that's our smart speaker, Aragon it's called, Aragon WL. This is a speaker that's running on the Wi-Fi, and this is also listening to the words that you are talking. It's waking up with the words "Hi Snips," and then it's interpreting with a natural language understanding algorithm what you are saying. So you can say also turn on the kitchen lights, and this will then send the message to our KNX gateway, for example, and will turn on the lights. So it's a rather easy way, you can see. Now, another point that you can see, there is no connection to internet. So if there is no connection to the internet, then it's not vulnerable. That's a big advantage. So there's no problem in the security for the data, and there's no problem for the security in the operation. Here a short table where you can see the differences of these two voice control types. At the left side, the online voice control, right side, the offline voice control. First point is the privacy. So the spoken data are recorded in online voice control. Offline voice control, you can be sure nothing is recorded. No spoken data will leave your home. Second point, the access from outside is necessary with an online voice control. I have showed you this, that this way between skill server and the gateway has to be open all the time. Next point, there are silent updates with the online voice control system, with the online assistants. That means even you're not aware of updates that are done by Amazon or by Google, because they will just make some modification in your home assistant and you're not even aware of that. This may influence your configuration. Well, with the offline voice control, there are no silent updates. Of course, you can do updates, but then you can do it manually. You are dependent on the cloud. This we have seen also. In offline, you don't need the cloud. You are dependent on the manufacturer. The skill service and the skill server has to run. And if the manufacturer is no longer working, perhaps it's going bankrupt, then you don't have any chance to make your gateway working. This is a problem that you do not have with offline voice control. Next point is the flexibility. With the big Amazon and Google companies, you can be sure that they will not hear on your private demand. If you have a special demand for a word or sentence, whatever that you want to use, it's not possible. They don't do it. Here in the offline voice control, you are independent and we can customize your commands. Yes, one other point that is very interesting is the CO2 footprint, because a 1 echo dot, it generates 16 kilograms of CO2 per year for the data transfer, just for the data transfer. That means only because the data are transferred from your home outside to the different servers and comes back, this will generate 16 kilograms CO2, which means it's as much as 100 kilometers with a small gasoline car. Well, CO2 footprint with offline, there's nothing because there's no data transfer. Well, there's also a big advantage, of course, for the online voice control. You can query anything on the internet, which is not possible with the offline. You can query when the plane leaves for Berlin, as I told you. You can ask how this is the noise of the cow. You can ask a joke. You can do a lot of things that might be even interesting and good for some people. Well, this is not possible with the offline voice control. And the costs. Yes, the costs. If you have a small installation, you will not believe it, but the online voice control might be even more expensive because you need additionally this gateway that has to have the connection to the skill server. In the offline voice control, you don't have it. But of course, if you have several rooms to automate, then you will need more than one of these assistants, and this will become more expensive then. So this is the comparison of these two systems. Now, one point I didn't mention until now is the possibility that you can use the assistant also for people that are living alone. You know, elderly people today, if they are living alone, they don't want to go to a house for elderly people. They want to stay at home, to stay the maximum time at home. And this is possible now, or here's a big advantage on our system, because we can allow staying at home longer. The voice assistant retrieves the data of the smart home. That means it retrieves the data from the presence detector, from motion detectors, from door contact. It's also recording the activation of actuators for lights and for blinds and so on. And everything, all these things are recorded directly on the system offline. And then with a machine learning algorithm, again, an edge computing machine learning algorithm, as we call it, we are predicting if the actual behavior is normal or not. So that's an additional function that's running directly on our voice assistant. And these records are done locally, as I told, and they are evaluated, and it determines the presence and absence from the resident. That means if the door contact has been opened and afterwards the presence detector does not see any motion anymore, then this will mean the person is certainly outside of this flat, and then it's not making any trouble. Of course, it doesn't say, hey, there's no problem. There's a problem. But on the other hand, if there is someone in the apartment, it can predict whether the time to get up from bed or the time to stay in the bathroom, in the kitchen, living room is correct or not. Because the other day, the person stayed only 2 or maximum 2 hours, for example, in the bathroom. And the next day, suddenly, it's 3 hours. So now the system becomes awake and it's saying, hey, do you have a trouble? Do you need help? And in this case, it is asking the resident before alerting to avoid false alarms. It's a very nice function that you can combine this machine learning functionality together with a voice assistant. So you do both on the same system. The system additionally enables an external contact via voice. So that means if the helper, the carer, is called, then he can call back to the person who needs help, and he can talk directly through our voice assistant to the person. So that's a nice feature, I think, that is not very expensive to install, because you only need at least this voice assistant and then the installation of the home automation to detect these anomalies. Well, now I will just present you our voice assistant. We have one that's called Aragon PoE, which is a system that is in a switch box, flush mounted. And then we have one table system that is just, as an Alexa Dot, as you know it, or Google Home Mini, has the same size, but not this functionality, of course. And these systems, they are connected to the KNX system, preferably by a server, because the visualization server has the advantage that you already configured all the room names and all the function names and all the function types. And these names are read out then from the server and will be trained. And then you can use these words to control also the whole home. So we can say, turn on the kitchen light, for example. So we're working with different servers, which might be the Gira X1, then the Young Smart Viso server, the Gira Home server also, if there is a quad client visualization that's installed and configured. And we have also our own server, which is a real Kinix Air server, which is also using, you can also use it for Siri, Alexa, and Google, because we started with these voice control systems. These are still available, of course. And additionally, you have the offline voice control. So that's just a small remark about that. You can use also only our ProServe gateway, because you can configure the whole visualization through ETS, through the ETS software directly in this gateway. And then this configuration is read out again from our assistants and will be trained. Then we are also doing automatic readout of SONOS. So that means if you have a SONOS system installed in the same room when the Aragon is installed, then you can just say, hey, play some music in the living room, or make the music a bit louder, or start please my favorite playlist, which is Supertramp, or you can say skip the next title, or you can even ask what is playing in the moment. All this is possible without any configuration. It's done automatically. Next point is also an IKEA TRUD-free gateway that is possible to use. It means the IKEA Vault is also available through this gateway. Well, of course, if you don't have one of these servers, you can use also just Kinix IP gateway, and then you can configure all these names manually in a file. That's also possible, but it's not so comfortable, of course, because here these are really plug and talk systems that we can use. Okay, that's about our systems. And if you have any questions or remarks, please mail us to info@prokinx.com, or you can have also a look at our website, prokinx.com. Thank you very much.